Okay, now this is an interesting problem because we don't really have rules to find the derivative of functions being raised to the power of other functions. We can find the derivative of, say for example, a constant to a function, or a function being raised to a constant power. These are no problem, but here we have a function being raised to another function. So we need to bring out the big guns. And the big guns in this case are logarithmic differentiation. Now, the first thing we're going to do is we're going to call this guy either f of x or y. It doesn't really matter. It's just a notation. Maybe I'll use f of x for this one and then y for the other one. So I'm going to call this guy f of x is x e to the x. Okay, and then what I'm going to do is I'm going to use the logarithms to help me bring this exponent down. So again, I use this whenever I have functions being raised to other functions. This kind of a situation. So now if I get the log of both the left side and the right side, left side, then what happens is that now I can use the laws of logarithms and bring this exponent down below. So this is going to equal to e to the x times natural log of x. Now this might look a little bit bad, but in reality, now at this point, if I get the derivative of both sides, now I can solve this problem because of implicit differentiation. Wonderful, wonderful tool, implicit differentiation. Now, you have to be a little bit careful. So notice here we have a function of another function. So we have to use the chain rule. Now, for this first part, the derivative of natural log, that's going to be 1 over the inside function, which we'll call f of x. That's what it's called, f of x. So 1 over the inside, we leave it alone, times the derivative of the inside. Well, the derivative of the inside, we're going to symbolize it by writing f prime of x, because obviously we don't know what it is. That's what we're looking for. Okay, now here when I get the derivative of this function, well, I have to use the product rule, obviously. So the product rule tells me, okay, get the derivative of the first, which is itself, times the second, leave it alone, plus the first, leave it alone, times the derivative of the second, which is 1 over x. Okay, well, this is great times here. Because now, if you look at this, I'm looking for f prime of x. All I need to do is multiply both sides by this f of x here, which is in my way. So I'll multiply by f of x, both sides. But notice that I know what f of x is. F of x is just my original function, x e to the x. So in the end, my derivative, f prime of x, is just equal to e to the x, natural log of x, plus e to the x over x, all multiplied by x raised to the e to the x. Magic. Math magic. Okay, now this one looks way uglier than the other one. But if you notice, well, first of all, notice we have a function being raised to another function, but then we also have this other stuff going on. But remember that when we have the laws of logarithms that say, for example, the log of when you have a product inside, you can break it up into two logs. that are adding. If you're dividing inside, you can break it up into two logs that are subtracting. And then this is the one that we used in the problem before. If you have the argument of your log has an exponent, you can bring that exponent out in front. Well, actually, we can use the first one and the third one in this one to help us with this problem. So, in this guy, the idea is the same. Now this time I'm going to call, instead of f of x, I'm going to call this guy y. So I'm going to say that y is equal to e to the x times x to the fourth plus 1 times x to the x. But I'm going to do the same thing. I'm going to get the natural log of both sides. And so on the left side, I'm going to leave it natural log of y. But now on the right side, I'm going to break it up. So I'm going to use law number 1 to break it up into 3, and law number 3 as well at the same time. So these guys, these exponents, are going to come out in front. So this first one is going to be x times natural log of, this one's interesting, natural log of e, okay, plus natural log of x to the fourth plus 1, plus, now this guy, x, is going to come down, so x times natural log of x. Okay, then the next thing we're going to do is we're going to get the derivative of both sides. So the derivative of the left side, derivative of the right side. Okay, so now on the left, the derivative of natural log of y, well, that's going to be 1 over y times the derivative of the inside, derivative of y, which is, I'm going to symbolize by y prime, or if you want to write dy over dx, that's fine. But y prime, for me, is equal to, now I get to get the derivative of all this stuff. Well, ln of e, that's just 1, so I'm not going to worry about that. But the derivative of x, well, that's going to be 1, plus the derivative of natural log of x to the fourth plus 1, well, that's going to be 1 over the inside, x to the fourth plus 1, times the derivative of the inside, which is 4x cubed. Plus, and now here I have a product, so I'm going to use the product rule. So let me do this one by one. So here I have the derivative of the first, which is going to be just 1, times the second, leaving it alone. So ln of x, plus the first, leaving it alone, times the derivative of the second, which is 1 over x. And these guys will cancel here. X and x. And then the last but not least, I need to get rid of this y, so I'm going to multiply both sides by y. But y is my original function up here, so that means that my derivative, y prime, is equal to 1 plus 4x cubed over x to the fourth plus 1 plus natural log of x plus 1. Actually, these two I could have added to be 2, but I'll just leave it like that for now. And then y is this guy right here, which is e to the x, x to the fourth plus 1, x to the x. That. And that's it. Magic. And these two, 1 plus 1 is 2, so you can add those for fun. Okay, now this is a very, very interesting problem. you can tell that if you tried to do this by using brute force, it would be a terribly, terribly bad time. Okay, so what other option do we have? Well, what we could do is use logarithmic differentiation, and it's very helpful whenever we have lots of products and quotients and chain rule situations. So I'm going to show you guys how to do that. The first thing is, let's call this guy right here, this whole thing, y. And so what I'm going to do, I'm going to write down right here y equals that whole thing. But now I'm going to write it out, instead of root, I'm going to write it out as everything raised to the 1/2. So I have this fraction, so this is going to be x squared minus 1 squared times x minus 1 cubed e to the x plus 1 to the 4th and 2x minus 1 to the 7th. Okay, now then I use my usual, I'm going to get the log of both the left and the right side. And then I'm going to use my my special patented trick for expanding logs. Alright, so in case you forgot, pay attention because it's going to go quick. Everything's going to go in one step. Now, here's the deal. We're going to use laws 1, 2, and 3 at the same time. First of all, notice everything is being raised to the 1/2, which means that everything is going to have 1/2 in front of it already. Now, when I break them up, these guys right here, these exponents are going to go in front of each log. So what I'm going to do is I'm going to multiply the one that comes down from each one of these to this 1/2, because the 1/2 is on everything. Okay. On top of that, remember that the factors that are on the numerator are going to end up being positive because of the laws, and the ones in the denominator are going to end up being negative, again because of the laws. But I'm going to do all of them at the same time. So, first things first, this first one I'm going to have, so this 1/2 is going to go down, and then the 2 is going to go down. So 1/2 times 2 is going to be 1 natural log of x squared minus 1. Okay. Now, plus, because this next one's on top, and then the 3 is going to come down. So 3 times 1/2 is going to be 3/2 natural log of x minus 1. The next one is down here, so it's going to be minus. Now the 4 is coming down times the 1/2 that was there, so this is going to be 2 natural log of e to the x plus 1. The next one, again, is going to be negative. The 7 is going to come down times the 1/2 is going to be 7/2 natural log of 2x minus 1. Now this looks terrible, but it's really not that bad, especially if you compare that to what it would have been. So then we get the derivative of both the left side and the right side. And on the left side, the same as in the last problem, we're going to have 1 over y times y prime times, now each one of these logs are going to have very similar derivatives, because or at least you're going to do it the same way. What you do is the derivative of natural log is 1 over whatever you have inside times the derivative of the inside. Well, so this is going to be 1 over x squared minus 1 times derivative of the inside, which is 2x. Okay, plus 3/2. the derivative natural log of x minus 1. This is just going to be 1 over the inside times the derivative of the inside, which is just 1. So 1 times 1 is 1. So you can write it if you want. But that's that one, minus 2 over, same thing, 1 over e to the x plus 1 times the derivative of the inside, which is just e to the x. Okay, minus 7 over 2, and then 2x minus 1, same for this one, times the derivative of the inside, which is just 2. And so these guys cancel. And then at the end, to get rid of this y, well, all I've got to do now is multiply both sides, how about green, by y, which is this initial monstrosity. So now all I have, y prime is, let me write it all out, 2x over x squared minus 1 plus 3 over 2 times x minus 1 minus 2e to the x over e to the x plus 1 minus 7 over 2x minus 1 all times this big huge thing, so I'm going to write it out, square root x squared minus 1 squared x minus 1 cubed over e to the x plus 1 to the 4th times 2x minus 1 to the 7th. And that's the answer.